if y is given to be equals to a function of x, as f of x, then the y dx can be written as f prime of x. Now, if the expression is being differentiated again, the second differential coefficient is obtained and it is written as d squared y dx squared. And this can be written again as f double dash x. And by successive differentiation, other higher differential derivatives can be obtained, such as the cube y, the x squared, the x cube, e raised to power 4y, the x raised to power 4, and so on. Now let's take for instance, we are given that y is equals to 3x raised to power 4. Okay, now we want to find an expression up to this e raised to power 5y dx raised to power 5 up to the fifth derivative. Now the first thing we do is evaluate the y dx. After we evaluate the y dx, we evaluate the square y dx squared, the cube y, the x cube. Okay, thereafter d raised to power 4y, the x raised to power 4, and finally x raised to power 5. So if we differentiate 3x raised to power 4, we are going to have 12x raised to power 3. If we differentiate 12x raised to power 3 again, we are going to have 36x raised to power 2. Differentiating 36x raised to power 2, we are going to have 72x. Differentiating 72x, we have 72, and differentiating 72, we have 0. Now all these are applications of our second video that says when we differentiate a function of a x raised to power n to give us n or an x raised to power n minus 1. And notice that the differentiation with respect to x of a constant is equal to 0. Let's take another example. Number 2. We are given that f of x is equal to 2x raised to power 5 minus 4x raised to power 3 plus 3x minus 5. And we are asked to evaluate f dash dash or f double dash of x. Now this f double dash is the same thing as writing the square y dx squared. That means we are going to differentiate f of x 2 times. In that case, let's differentiate the first time, and secondly, we will differentiate the second time, because this is an expression for dy dx, and this is an expression for d square y dx squared. So differentiating 2x raised to power 5, we have 10x raised to power 4. Differentiating 4x raised to power 3, we have 12x raised to power 2. And differentiating 3x, we have 3. And differentiating 5, we have 0. Let's differentiate f dash of x or dy dx. Let's differentiate again to get the square y dx squared. Now we'll have 40x raised to the power 3 minus 24x. Now let's take, for instance, we want to differentiate up to the third term. Then we'll differentiate 40x raised to the power 3. That will give us 120x x squared minus 24. Again, let's take another example. Number 3. We're given that y is equal to 3 sine 2t plus cos t. And we are asked to find the second differential coefficient with respect to the variable. That means we are asked to evaluate dy dt and the square y dt squared. Now let's evaluate dy dt. And we are going to be applying two principles. That's when we differentiate sine at, we are going to have a cos at, and when we will differentiate cos at, we will be having a minus a sine at. Therefore, differentiating 3 sine 2t, these are examples that we have done in differentiation of y is equals to sine ax. That's the third video in this series. Differentiating 3 sine 2t, we'll be having 3 multiplied by 2 cos 2t. And differentiating cos t, we will have minus sine t. Simplifying, we have 6 cos 2t minus sine t. Now we want to evaluate the square y dt squared. Differentiating 6 cos 2t, we'll have 6 to minus 2, applying this principle of cos 80, we have minus 2 sine 2t minus, and differentiating sine t, we will have cos t, and this will give us minus 12 sine 2t minus cos t. Let's take another example. Given y is equals to 2 ln 4 theta, we recall that when we differentiate with respect to x of ln ax, the answer will be 1 over x, irrespective of the value of a. Now we are differentiating up to the second differential coefficient. That is, we are going to evaluate the y d theta and also evaluate the squared y, or the theta squared. Now the y d theta in this case is going to give us 2 over theta. Now 2 over theta, we have to differentiate it again. So let's write it in the format of indices. This gives us 2 theta raised to the power minus 1. Now we can differentiate this now, and this will give us, let's apply the principle of a x raised to the power n to give us a n x raised to the power n minus 1. Since our a in this case is 2, and our n in this case is what? Minus 1. So this will give us 2 multiplied by minus 1 theta minus 1 minus 1 minus 2 theta raised to power minus 2. And writing further or simplifying further, we can rewrite as minus 2 divided by theta squared. Now in our next video, we'll be considering more examples or further examples on successive differentiation.